Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of rate of change. This is standard A.3B in the great state of Texas, and we are using item number 9 off the Redesign Practice Online STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a fish tank here that's being drained at a constant rate. We have a linear relationship between the volume of water and the time in the tank. So I'm going to scroll this up here, kind of obscure the top part of the graph, but really I want to have all four answer selections shown here. So let me open up my graph draw feature, expand it out, increase the transparency, put the draw button on. So now I can draw on this. I'm going to make the transparency 100%. I don't need the grids to be sitting on top of this graph here. So which value best represents the rate of change? Okay, we're looking for the rate of change of the volume of water in the fish tank with respect to. Okay, so those two words are going to give me a clue as to what we're looking for. So with respect to, it's just another way of saying per. So I'm looking for the volume of water in the fish tank per time. And that per with this rate right here lets me know, since that rate can also be written as ratio, we're dealing with a ratio here. And what am I looking for? I'm looking for water, volume of water, per time, or with respect to time. So this is what I'm looking for. I'm looking for the rate of change of the ratio of the volume of water per time, or with respect to time. And let's see, my time here is on my x-axis, and my volume of water, you see there at the very top, it is the y-axis. I'm not going to scroll that up. You can see that at the very, very top. And I'm looking for the rate of change. So I'm wanting the change in water over the change in time. And I'm using the Greek letter delta, which looks like a triangle. That's what signifies change in math and science. So the change in y over the change in x. Hopefully that is making you think change in y over change in x. That sounds an awful lot like rise over run, which is slope. And if you are thinking slope, you are correct. So if you needed it, we have a reference chart here. Remember our slope. I'm going to put it right at the very bottom there. Slope of line m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So that's the equation we'll be using here. And so we're really just looking for this rate of change, which is just the slope. So we're going to pick two y coordinates, subtract them, and put that over to x coordinates, subtract them, and there we go. We'll have our slope. So we're looking for coordinates that are exactly on an intersection, and really the only two I'm seeing are the two intercepts. Okay, so I see this first intercept as 10, 0, and I see that one over here as 0, 60. My x and my y intercept. But that's fine. We can make those, as long as we have 2 points, I can make that my x1 and my y1 for the 10, 0. Make this x2 and y2 for my 0, 60. So once we do that, let's just plug that in. 60 is my x2, or my y2, excuse me, minus 0. That's easy. It's going to make 60. And then I've got 0 minus 10. That's going to make negative 10. So we could just drop the zeros off. It's 6 over negative 1, which is just going to be negative 6. Now, does that make sense? Yeah, because first off, it does need to be a negative, because look, it's a downward slope, right? So we can get rid of B and D, and then this rise over run means for every one it goes over, it goes down 6. So it's going to be a pretty steep slope, right? And so we've got that negative 6. And obviously we see the reciprocal negative 1, 6, but we know that's not it. Our answer here is A.